Welcome back to the aluminum wheel TIG welding repair part 2. If you watched part 1, you saw that we skipped some steps. We took a minimalist approach to diving into this project. Now in part 2, you're going to see the conclusion and where we went from here. Well, I came out to the shop this morning and my worst fears were confirmed. Overnight, this thing developed a crack right back in the same area that we welded it. It's not surprising, it happens, right? But I did everything I thought I was supposed to do. I drilled where the crack was, where the visible crack was, and then I cut right down the crack that was there all the way from the edge down to that drilled hole where the crack had terminated. So I cleaned it really good. I used AC TIG with a low balance setting, had a pretty decent looking weld. I had sanded it down and was looking just at a little bit of porosity in there, and it wasn't very deep. So for a casting, that wasn't too bad. I was pretty happy with it. So I thought, man, I come out here this morning, fill in some holes, just do my final touch-ups before I blend it back down and get this back to the customer. But unfortunately, I saw a crack. So that led me to exploring with an 1/8 inch drill bit, and I started to drill back into the crack and look at it, right? Because we're into this thing, and there really is a never say die moment here. We're going to get this right. Again, it's a learning situation. It's not something that I do every day, and it's not for a highway speed application, right? This is just going to be used around the shop. So not really too concerned about strength. What I'm concerned with is stopping the leak and making sure that this thing doesn't crack again. And like I said, challenge accepted. Let's see if we can do it. But what I found, and this is my speculation, this thing was repaired once, and of course I couldn't see the repair because it was blended down. But the more that I started to dive into the metal around my weld, I started to see some trash, what either looked like a really bad casting with some parting lines in it, or this thing was welded in a bigger area than I thought, and that trashy weld had some discontinuities in it that found their way right back into my weld. So I started to drill in, I started to make a bigger gap, I drilled down in until I found clean metal, because that is the only way to repair a casting. You gotta get down to the clean metal. So that's what we're going to do. I am going to run some preheat today because yesterday I got a little cocky and thought that I could get it done without it. I mean, I've done it before. This isn't the first rim I've welded on. But at the same time, I want to do everything by the book because I don't want to do this again. So we're going to do it step by step. I'm going to add a little bit of buttering to each side of this joint. And buttering is basically where I take the ER 4043 and I don't worry about making the weld joint. What I'm going to do is lay a buttering pass, a really thin pass of 4043 on each of the exposed edges. And that's going to be my trashiest weld, right? It's going to pull up garbage. It's going to spit at me coming out of the casting, and God knows whatever weld metal is there. So that light pass is going to give me a nice surface to bond to. And when I come back around and start to build the edges up toward each other and then weld in the middle, it's going to give us a greater chance for success. And that's what I'm looking for today, a greater chance for success. All right, so we're going to keep drilling. We're going to keep working on this thing. Like I say, I do not want to do it again, so I want to make sure we get all the junk metal out of there, and that I don't just rely on following the crack I saw, which I did, cut right down through the crack. Should have been no problem to put that thing back together. But what I'm finding is it wasn't as easy as I thought. Again, we believe this is an A300 or some type of a 300 series casting, probably A356 from what I can tell through my research online. So it is actually a heat treatable alloy, which means this thing has been heat treated. So what happens when you weld aluminum is that area around the weld, called the heat affected zone, is going to relax and soften, right? Because we're going to see that reversal of the heat treat process in this area. And that's one of the things that you want to be cautious about when you're welding rims, or if you have a rim to be welded, take it to somebody who knows what they're doing, right? This is on the edge of the scrapyard, so we're not really concerned with overall performance. It's not going back on a sports car, and it's not going to be rolling at 75 miles an hour down the highway. So I've got a little bit of a luxury of learning as I go and trying some different things to make this work. And like I say, our primary concern here is to stop the leak, not to come back with factory strength. So that being said, a couple of ways to do preheat on this. And as we talked, one of those ways is using oxy fuel and the sooting method, where we get a sooting flame and we allow the soot to build up on the surface of the aluminum. It will condensate on the surface. And then we kick up the heat and we just burn the soot off. And we, at least in theory, we know that by the time that soot burns off, we are approaching the right preheat temperature to start our welding process. And preheat's going to do a couple of things. It's going to remove moisture. It's going to remove those hydrocarbons, any oil or grease that's embedded into this thing. And it's also going to slow the rate of cooling, right? We preheat because it slows the rate of cooling. It doesn't quench as fast. It's going to allow any gas pores that are there to off gas. One of the things that can happen, especially if you're welding with an inverter power source, they form a puddle a lot quicker than the old conventional machines, right? You've got a higher balance setting, you've got a more focused arc. So when you weld on cold aluminum with an inverter, what you're gonna have is a greater quenching effect from the base metal around it, because you weren't there waiting to form a puddle as long. It's gonna quench that weld and try to suck that heat away faster than in the old days. So preheating is going to stop that. It's going to remove some of the thermal shock. And remember, we don't want to preheat over 250 degrees on aluminum, because any hotter than that, and we could be approaching the aging temperature, which could overage the material and cause reversal of all that heat treating that we've done, more so than welding, right? Okay, so that's what we're going to do. What I'm going to do also is I'm going to use my temperature probe here, which is a little bit more accurate reading. And I'm going to go ahead and take readings in this area of the weld so that we can verify that when we're actually doing the sooting method that we are in the ballpark. And if not, we'll adjust accordingly. So let's see if this process actually works, right? Once I started going down my crack and I saw another crack here, which is interesting, I went ahead and noticed that there was some material that wasn't fused properly down in the edge of this groove here. So I took my drill bit and I chased that area over here. This is the porosity that I was just going to cover up today, right, with a little bit lighter pass. And anytime I see elongated porosity with a jagged edge, you know what that tells me? That's not porosity. That's that crack, right? Going all the way back into here. Now, I did not get into the shoulder, and this would have been probably right in here, about halfway between my groove and this shoulder is where the original crack was. So I'm going to do some more drilling. We're going to do some more exploring and make sure I can get this thing put back together correctly. Now, the good news there is I don't see that porosity extending below the surface. I just tried to drill into it to see if it would open up a crack, and I'm not seeing anything so far. We'll keep going and just see what this looks like. Now, here's something I'm noticing as I'm drilling in here. If you look in the end of that hole, can you see the black line in there? Now, why would there be a black line or a parting line way back in here? I should be able to see basically smooth, clean aluminum, just like I'm seeing at the end of this drill hole. But instead, as I get away from where this crack was, it just gets trashier and trashier and trashier. And I followed this probably 1/8 of an inch in here. So then I wonder, well, how wide was that original weld zone when they repaired this, right? Makes me think I don't have all the information. So as I'm getting this thing cleaned up, I wanted to take a closer look and just make sure that I'm not seeing any cracks that I can't see, you know, from this distance away with the naked eye or with my corrected vision. So what I did is I pulled out my little digital camera. I've used this for a number of inspections, and it gets pretty close, lets you see everything on your phone. So let's take a look at this thing and look at what we're dealing with up close and personal. This is at 10x on the digital microscope, and lets us see all these areas of garbage and incomplete fusion and oxides. And digging back into this, I think the biggest thing is when something's been previously repaired, you can't assume that any metal around that crack is any good at all. And further exploration here with a drill bit has gotten me back into some clean metal now. All right, so we got that thing open way up, trying to get out of trashy metal that was either in the original casting or that was put in here by the previous or during the previous repair. So I was seeing lots of stuff down in there. What we've done here is tried to smooth this down the best we can. I'm going to come back in here and wash this with a TIG arc after we get it preheated on both sides. So it's going to be a little flipping around. And we're just going to let the trash burn out. I'm going to re-clean it, and then I'm going to go back in through here with some ER 4043, and I'm going to concentrate on putting a buttering pass on each of these sides. And I'm going to be watching for any cracks to open up. All right, let's apply the soot method. So what we're going to do is we're going to soot that up just like that, okay? Now, I'm going to turn that up so it quits sooting. There we go. Dial in a neutral flame by dialing the feather back to those light blue cones. Now let's see what we got here. Definitely burning that soot away, right? All right. 310, 320. So in my mind, that's a little bit warm. That's hotter than I had hoped to get it. I wanted to definitely get it up to that 220 degree range Fahrenheit, 100 degrees C. And I think the sooting method got it a little bit warmer. So at the end of the day, be careful if you're using that method. I strongly recommend using one of these HH12C Omegas. This happens to be a fluke temp probe that just plugs right into the end and gives you a pretty accurate reading there. A lot more accurate than if you're using one of those infrared guns. Those are not recommended on shiny material, right? Because it reflects. It doesn't give you an accurate reading. So if you're using those, stop it. Get something better. Temple sticks are better than that. Okay, we're ready to start. I got this weld. I'm going to approach right here in the flat position because that's going to be the easiest position to weld in. So we're going to use gravity to our advantage here and put that first buttering pass on there. All right, that looked good. So we just washed over it with a light AC TIG arc and kind of got a little bit of a puddle to form on the edge. Now we're going to clean that back up, and I'm going to see if it'll take some rod. All right, that's going to be the ultimate test. So let's butter it up. Okay, we're getting a nice thin layer on that edge. So we're going in the right direction. We're going to keep doing this till we get her welded up. So let's butter it up. Okay, we're getting a nice thin layer on that edge. So we're going in the right direction. We're going to keep doing this till we get her welded up. So this is what that looks like. Buttered on the top. I flipped it over, buttered it on the bottom, and now we've got a nice radius of good, clean aluminum all the way across there. So I'm liking how this is turning out. I just sat here at the start a little bit and let some of that trash pop out, and then boom, 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 started dipping in just a little bit of rod at a time. And made sure that I had good fusion and that you can't see any of the edge of that weld where it comes up against the base metal and didn't tie in. So, hoping for success. Wish us luck. Okay, so check this. I had 3 holes from hell open up when I was welding on this. One of them was right over here, and I was able to deal with it. The second was here. The first was here. The second was here. I can still see a little bit into there. I'm going to feather it in. And then if you can see that, that jumped out from basically the area that I was welding in. I thought I had it clean good. I'm guessing that's part of the other weld that I was seeing. So we got a little bit more cleanup work before we come back in on this. We're going to let it cool down so that it's cool to the touch to make sure we're keeping our inner pass temperature low. Well, this one's been a little bit squirrely. Trying to stop this rim from leaking by welding up a little previously repaired section of the rim. We've got the bulk of the weld done. We've feathered it down, and I don't see any major discontinuities with it, so we're off to the races. Today's goal is to just get this weld finished up, get it finished off on the top, add metal where we need to, and get it recontoured so we can put the tire back on and do a leak check. So here's that edge weld. We were just building up the surface along here, and you can tell by how clean and shiny the weld is that we've got through most of the crud and we're getting a decent bead appearance. When I first started welding on that, the weld did not look like that, right? It was trashy. It was pulling stuff out of the casting. It was pulling stuff out of the previously done repair patch. And now I think we're into good metal and we're seeing good results. So we're going to keep on rocking and get this thing done. All right, stainless steel wire brush this. And now we're off to the races. Okay, so here's some of that edge buildup that we did right there, just to make sure that when we contour this, we end up with a nice flat surface and no big dips or dives, right, that are going to cause this thing not to seal. I traveled a little bit slower than normal because I was still noticing some porosity bubbling out of both of these welds. So I just let it go ahead and off gas, and then I dipped a little bit of filler rod and I moved forward when I didn't see any volcanoes opening up. Well, I've done this entire casting project and this wheel repair using the Lincoln Square Wave 205, which is a little AC/DC TIG and stick welding inverter. And I gotta tell you, for me not knowing what I was getting into and running into some of the trash and garbage in this casting, one, because it's a casting and they're notoriously porous and dirty, and two, because it had been previously repaired, resulting in a weld that cracked, right? So I had no idea what I was jumping into, and I saw some interesting things over the last couple of days as I opened that can of worms and peeled the onion layers back, right? But every time I needed it to, I stomped on the foot pedal and this little powerhouse did everything I needed it to do. I'm getting really good beads. It's super easy to weld with, and I've got plenty of range to weld on this material that's a pretty good size casting, right? It's not all that thick in different areas, probably down to around 1/8 of an inch. And then in some of the corners and bends, it seems to be up around 3/16, maybe even 1/4 inch. So I'm happy with the performance. I'm glad I've got this thing in the corner, and I'm glad that we're able to knock this out and learn something along the way. If nothing else, I'm showing you what not to do. So here you'll notice as I'm TIG welding, I've positioned myself so that I'm welding towards my body, and that allows me to have really good visibility of the weld puddle. It also keeps me from going right to left and having that natural arcing motion, which takes a little bit more manipulation to keep the torch on track. So I found if I weld at a slight angle, maybe 45 degrees toward myself, gives me really good visibility of the puddle. You're also going to notice that my TIG torch, based on the position of that back cap, is nearly 90 degrees. I'm going to say probably 75 degrees, and that's pushing the puddle towards me, which gets that oxide cleaning from the AC arc out in front of the puddle to remove the oxide before I try to add any filler rod. If you look at my filler rod, it's very, very low. In fact, I like to say it's at about a 90-degree angle to the TIG torch, so I try to add it as flat as possible. I keep the filler metal slightly away from the material surface. I don't want it to soak up any heat before I'm ready to go for the puddle. And then I dab in it and try to maintain a decent frequency as I'm going, and that gives you a nice good ripple pattern. So a couple things to keep in mind here. One, try welding towards yourself, gives you better visibility of the puddle. And two, keep that filler rod as low as possible, down to about a 10 or 15 degree angle, so it can sneak in the front edge of the puddle without getting flashed by the arc. Now that's the kind of weld I'm looking for. Nice, clean, shiny appearance, no pores, no cracks. That's what we want. I like it. Okay, I just want to point out a couple of things here. You'll see that from this point back on the lip, I had to weld all the way to that high point back there and fill that crack in. So what you're seeing along the edges here, some people have commented that they believe that was a crack. And those are not cracks. Those are the toes of the weld that haven't been blended in around it yet with the base metal, because I didn't want to do a whole lot of blending until I got this thing done. So I did minimal amount of blending to make sure that I liked the contour, that I wasn't seeing any cracks or any major porosity or nasty trash underneath the surface of the weld bead, because that's often where it'll show up, is just below the surface. And then what I'm doing here is I'm working my way from the lip back down. I'll be filling in any of the visible porosity that I can see just as a precaution, making sure that I blend those toes in so that I have a nice transition from the weld back into the base metal. So just in case you're wondering, that's what you're looking at here. And again, it's very common to see porosity in castings, especially aluminum castings. They're notorious for being trashy, right? They have gaps and voids in them. And a lot of times when you start welding on it, things are going to bubble up and spit out at you. This is the part every welder hates. Take a perfectly good weld and we got to blend it back down and shave off all those nice shiny ripples. So I don't know, I had fun with this project. I kind of got a little cocky and wanted to show two different approaches to welding, right? The minimalist approach that cuts right to the chase, like we've all been asked to do. Just weld it up. You don't need to take any time with it. Just weld it up, and then they expect the weld to be perfect. Well, that's not how life works. Prep matters just as much as the weld, if not more. I can't tell you how many times in my life poor preparation made welding a disaster. You know, when you skip prep and you try to do things under the gun and you don't take your time, it's a disaster that can just kind of compound and snowball together. So this was kind of a good illustration of that. The second time that I did it, I followed more the outline that I had prescribed in the initial one that I decided to skip, and it was opening that thing up a little bit more, chasing all the trash that I could see, and not just thinking, hey, we can do it good enough and no one will know. Well, that wasn't the case, right? So at the end of the day, I got a lot of comments, a lot of really good feedback from folks that do this for a living. I am not doing this for hire. I'm not charging for it. This was an experiment. I thought, what a great opportunity to learn something. And here's what I learned. Don't weld on cast aluminum rims because, one, they're heat treatable. And when you weld on heat treatable aluminum, you soften the material and you reduce its tensile strength by up to 50%. It's in the aluminum code. Especially for a 6061 type alloy. This happened to be A356, and I don't have the exact specs on what we could expect for a loss in strength there. I'd have to look that up, but it's going to be very similar to 6061, right? We go from it was in the case of 6061 in the unwelded condition, we go from a tensile strength of about 42 to 45,000 pounds per square inch to the as welded condition must meet 24,000 psi. So that is nearly a 50% reduction, right? And I often joke that it really doesn't matter what filler rod you're using, 4043, 5356, because the tensile strength of both of those fillers is above 30,000 psi, and therefore above the 24,000 minimum required by code. Now, there are arguments to be made that 5356 brings some other benefits over 4043, and vice versa. 4043 offers some things that 5356 doesn't. In the past, I have welded on some off-road rims for some folks that like to go play in the sand dunes, and I've always used 5356. In this case, the research that I did said, hey, if you're having cracking issues, you may want to try 4043, 4943 if you're into that. But at the end of the day, the consideration there is 4043 has less crack sensitivity, and it may resolve some of those associated challenges. So I went ahead and went for it. Again, on the second one, things went pretty well. We ended up welding it without any boo-boos. And I haven't heard if this thing holds air yet, but that's my next step, is to go and talk to the owner and find out if this thing's working on his little beater yard truck. So at the end of the day, it was a great experience. The other thing that I wanted to bring up, I guess before I cut to the chase, is this thing had been previously repaired. Okay. And as a weld shop, I've learned to not trust anyone anymore. I've had many things brought to me and been told a story of how something supposedly happened and, you know, can you just fix it for us? And 9 times out of 10, you're not getting the story. And one, sometimes they don't know the whole story, right? This was sent off to a shop that was supposed to have straightened the wheel and then re-welded it. And I'm telling you, what I saw shocked me. If we were to look at the weld, the visible weld on the black side of the rim, if you will, the side that you could see when it was installed, had a series of spot tacks, right? I happen to have seen those millions of times in my career. Each one of them had a little fisheye in it. That's how I could tell it was a series of tacks and not whips that were too far away, right? So I'm seeing this. I'm seeing kind of spattery lack of fusion at the toes and wondering, wow, was this a dirty casting? Or did whoever fixed it try to do it with a spool gun? Because once I started digging into the crack area around where my weld cracked, right? Because I did a textbook thing. I drilled the hole out, chased the crack, welded her back up. Oh, it cracked again. So once I started to explore the area around that weld, I found out the whole thing looked like it was full of, right? If you've ever welded with a spool gun, you've seen that stuff build up. And if you don't have things tuned quite right, you're a little too cold. Yeah, a little too cold. And maybe not cleaned enough, you're going to get that cauliflower appearance where that aluminum wants to build up and then have these black marks all around it. And then when you weld over it, it doesn't fuse together. And that's exactly what I saw inside this wheel. So it was either repaired by a really bad TIG welder or somebody tried to spool gun this. Hey, but I hope you enjoyed the video. And if you didn't find it informational or educational, I hope you found it entertaining. And remember, whatever you're doing out there, if it's working, keep doing it. And until next time, keep your hood down. Don't stare at the bright lights.
And remember, this was already a botched repair. When you skip steps, take shortcuts, weld over someone else's mistakes, things have a way of coming back to bite you. Thanks for watching.